the representation of an error. How we can represent error? That's the main representation of an error. So the first thing is we usually have a way called absolute error. What we have? Absolute error. It is just a way of representing the error. So what this absolute error is, students, very quite simple. I am using the same symbol. In fact, I have to point out again here. Keep in mind that y throughout will be a exact value if you know it, and y cap is a approximate value. So absolute error is defined as y minus y cap. And whenever you compute this quantity, you need to take its norm. That is, you are only interested in the positive value, or in other words, the magnitude of the error. When we are only interested in magnitude of the error, so we usually compute absolute error. Now, point is, what does this mean? So if I go back to the example on the previous slide, which is this one, so you can see that my main target is to compute the approximate root, but there are two chances. I may end up on the left hand side of the root as well, or on the right hand side of the exact root. So let's say x dash is lying on the left hand side and x double prime lying on the right hand side, but only one thing will happen in real time. So point is it because we are applying approximate technique, is it worthy to have this information that we are on the left hand or right hand, rather than this thing is important, or this point is important, that how far we are from the root? So in this case, when we are trying to find the XR, the important thing is for us that we just want to know how far we are from the root, is irrespective whether we are on the left hand side or the right hand side. So whenever this thing in your mind, basically we want to compute the magnitude of the error, because as whenever I say how far we are from this root, so we mean that we want to compute the difference between the actual value and the approximate value. It could be on the left hand side as well, or on the right hand, which means negative or positive values. So sometimes we are not interested to compute the error in the sign with sign, that is positive or negative. So in this case, when we are not interested, we are mostly interested in the magnitude of the error. And whenever we are interested in magnitude, so we just want to compute the norm of the error. That's the main point. Okay, so this is the one of the way. For example, the for example, the y value of certain calculation is 2, and the approximate reading that you come up with is 2.001. So if I ask you what would be the absolute error here, so your answer is 2 minus 2.001 bracket modulus. This you want to compute, and answer would be 0.001 absolute. There is no chance. On the other hand, if y is something like 1 point, let's say, in fact still 2, let's say y is still 2 and y cap is something around 1.9, for example. So if you ask you to compute the absolute error, in this case the error would be exact value 2 minus 1.9. The answer would be 0.1, because we are taking the absolute. So 2 minus 1.9 will give you this reading, and this will be positive and this will be negative. In this case, I forgot to point out that this, if you subtract this one, this will be a negative value, so this will gives you but absolute value gives you the positive quantity. In this case, the value is positive inside and absolute So in both cases, we will get the positive result because we are only interested in the magnitude of the error rather than the difference, either increasing or decreasing or sign. So in this case, we usually compute absolute error, ABS error, usually written as ABS dot error. I hope you remember this simple calculation. Move ahead. What are the other options we have? First, we can compute something called relative error. Number two is called, let's number it. Number two, we can call it relative error. Relative error. So question is, what is relative error then? Relative error, student, is not something different thing. Basically, you just need to compute the error, and after that you can manipulate your error to make it much more representable or more understandable. So for example, it is called relative error. Relative error, relate, means you have to represent your error by relating it with something. So how do we compute relative error? It's very simple idea. Relative error is, it usually defined as the absolute error divided by, now this is the interesting part. I am giving you a one definition. Relative means you have to express your error, quantity of the error, magnitude of the error based on some other quantity. So what I'm doing here, I'm defining the relative error based on absolute error divided by the exact reading, exact value. That is, whenever I say exact value, we know that this means we are referring by quantity. So what I have to do, for example, in the previous example, I use a y equal to 2 and y cap equal to 0 point, I use 2.001. So this is the exact value and this is the approximate value. So relative error in this case would be absolute error, that is exact value minus approximate value, absolute, divided by the exact value. In this case, exact value is 2. So whatever be the answer of this quantity is 0.001 divided by 2 would be your relative error, relative quantity, which means that basically you have relate your quantity with the uh, exact value. So in this case, if you do so, basically, so your answer would be 0.005, which means that the error that you have in your quantity is 0.00 parts of the actual value. It is very simple way. Yeah, means you just, whenever you divide something, it tells you how many parts of this quantity this amount is. So it is 0.005 times this error contains. So it is just a relative error. Relative error could be any value because it depends on the error, but it is defined like this quantity. Sometimes we can remove the absolute part as well. We just want to compute the error. We can divide the error by the certain value as well. So in this case, if you divide with error only, you can get a negative or positive sign with it. So in this case, you can say -2 relative error or 3 relative error. That's also possible, just to represent whether increasing and decreasing. But usually it is defined in the sense of absolute error. So I gave this example. So student, I hope you understand that it is just a basic concept that you have exact reading, you have approximate, you can want to compute, okay, this is an error. Now you want to compute, you want to present these results. So how you can do it? You can present in the form absolute error, relative error, and other form as well. For example, the third form is called percentage error. It is very simple error. You can also understand why it is very simple. It's called percentage error. So what we do, we express our error in the form of percentage. So in percentage error form, That is percentage error. What we can do, we can define it like that. We can define with the absolute value as well, or with general error as well. Let's do it with absolute value again. Absolute error divided by whatever be the exact value, y in this case, and whatever the answer you get, you have to multiply that quantity by the factor of 100 to make it percent. So what we are doing, for example, absolute error upon exact value, whatever the fractions come, we need to multiply it with either 100, just to know that what percentage this quantity is. So for example, in the previous example, the absolute error is 0.001 and the correct reading is 2, which will end up, and I want to compute percentage error, I need to multiply by 100. So basically what I have to do, I have to multiply 0.05 by 100. So whatever be the answer is 0. This answer is 0.05%. Here we will call it 0.05%. So what does this percent means? Percent means here the error in the quantity is 0.05% of the actual value, that is y value. The complete answer is it is the percentage of the actual value. So sometimes we refer or we express our error in this form as well. So this is very simple strategy. It's not that difficult topic. It's just to recall all the points, because we will use some of these error formulas in the later stage. Also, this topic is usually related to the start of the numerical analysis. So in this, it is considered as a building block topic as well. So I hope you already used these formulas before. It's just to have some idea. So percentage error. Now these are, whatever we have discussed is relative error, absolute error, percentage error. These are just the representation of an error. How do you represent the error? But one thing before move ahead, I just recalled, it is not necessary that you always compute the error of multiplying by 100. Obviously, when you have to compute percentage error, you have to multiply by 100, but you can also compute error in the sense of per thousand. You can per million. So what you have to do, you just need to simply multiply by that amount. For example, if I want to compute per thousand error, I simply need to multiply the absolute error divided by exact reading by 1000. So whatever I will get, I said this is per thousand. So percentage is percentage means 100. So per 100, this is the value 0.05, or absolute error can be expressed in the per thousand, per million. It is depending on the quantity. Sometimes the quantities are very small that it is better to represent in per thousand or per million. So have some recent number. So this is just an idea. So do not memorize that, okay, there is only 3 errors, absolute, percentage. You can do it with different errors as well. You can express, for example, you can use relative error concept by making a, by changing the following, that absolute error divided by the approximate value. You can do it like that as well. What you are trying to say in this case, that change absolute error at what times it will be the approximate error. I can replace it by bar as well here. So it depends. So relative is just to make the error relative to certain quantity, that how many times of this error of that amount. Percentage is just to representing how many parts of the 100 this error represents, and you can express it per thousand, per million, per trillion as well, depending on the quantity. So this, the concept remains the same. So let's move ahead.